Hi, my name is Janani Ravi and welcome to this course on applying differential equations and inverse models in R. A little about myself. I have a master's degree in electrical engineering from Stanford and have worked at companies such as Microsoft, Google and Flipkart. At Google, I was one of the first engineers working on real-time collaborative editing in Google Docs, and I hold 4 patents for its underlying technologies. I currently work on my own startup, Lunicorn, a studio for high-quality video content. In this course, we will explore a wide variety of differential equations as well as an unrelated technique known as inverse modeling and learn how we can apply these techniques using the R programming language. First, you will learn how many different physical, chemical and financial phenomena can be modeled using differential equations. You will see how population growth, the spread of infectious diseases, the pricing of complex financial derivatives and the equilibrium in a chemical reaction can all be modeled using differential equations. Next, you will discover how different types of differential equations are modeled and solved numerically. You will see how a mix of algebraic and differential equations forms a system known as a DAE or differential algebraic equation, and how a time-varying relationship between the dependent and independent variables can be modeled using delay differential equations. Finally, you will explore how initial as well as boundary value differential equations work. You will round off this course by understanding even-determined, underdetermined and overdetermined systems and working with such systems using R programming. When you're finished with this course, you will have the skills and knowledge to apply a variety of numerical procedures to solve differential equations using R.